Welcome to CE 402 Environmental Engineering 2 Module 5 Part 5. In this session I am going to discuss about the oxidation ditches. This method is designed by Dr. Parveer of Netherlands, and it is a basic operation that is similar to that of activated sludge process. It can be used in a situation where the activated sludge treatment or conventional or extended aeration is appropriate. This can be used in connection with the activated sludge treatment. It is designed as an activated sludge process with a long solid retention time to remove biodegradable organics. It is economical, highly efficient, involving simple waste treatment principles and comparable in performance with the oxidation ponds. The process involves a single unit treatment in an endless channel equipped with a special type of rotor which serves the dual purpose of oxygenation and circulation. In the oxidation ditches, according to the size of the oxidation ditch, number of rotor units are provided. These rotor will rotates and this will provide the function of reoxygenation, that is the air circulation or aeration, and it will also provide the circulation. The ditch comprises of trapezoidal cross section of relatively shallow depth 0.9 meter to 1.5 meter in order to enhance the aeration, and it is a continuous circuit. There is normally no primary tank and the raw sewage passes directly through the bar screen to the ditch. The oxidation ditch forms aeration basin where raw sewage is mixed with the active organisms in the ditch, and it will convert these unstable compounds into stable compounds. The cage rotor entrains the necessary oxygen into the liquid and keeps the content of the ditch mixed and moving, and also the oxidation takes place. And it will enhance the physical and biological process in which small portion of the organic matter undergoes direct chemical oxidation while the bulk of the organic matter is stabilized by biochemical activities of the microorganisms present in the system. Then the mixed liquor in the ditch flows to the clarifier for separation. The clarified liquid passes over the effluent ware for disposal into the receiving stream, while the settled sludge from the bottom of the clarifier is removed by pumping and returned to the sludge ditch for undergoing treatment, because it is same as that of the activated sludge process. Then the construction of these oxidation ditches, it involves the construction of number of ditch channels placed together side by side, having a depth of 1 to 1.5 meter. The width of the ditches is limited to the type and availability of aeration rotors. That is, depending upon the size of the rotor, we have to fix the width of the oxidation ditches, and may vary between 1 to 5 meter. The length of the ditches is not important, but some effort may be made to keep the perimeter of the walls to minimum when two or more ditches are used side by side. The length may vary from say 150 meter to 1000 meter or so. That is, length of flow will be that much. This you can see in the coming slide. That is the picture plan view of an oxidation ditch. The oxidation ditch may be constructed either in earthwork or with earthen embankments, or with the help of a brick or stone masonry with vertical walls. But um, it won't get eroded, and whether they are constructed in earthwork or masonry, water tightness should be ensured, and each ditch channel is usually equipped with a special type of horizontal axle rotor, and the sewage velocity should be more than 0.3 meter per second. Then in the thoroughly aerated sewage is then settled in the settling tank by stopping the rotors for about 2 hours and then taking out the clear supernatant through the outlet part of the oxidation ditches. And a part of the settled sludge is used for recirculation, and the excess settled sludge can be removed. Well stabilized sludge can be removed due to this long detention time. The sludges will be well settled and stabilized, and it can be easily dried on sand beds and disposed of suitably. Normally, the flow of oxidation ditch is aerated and mixed with the return sludge from a secondary clarifier. The preliminary treatments such as bar screens, grit chambers are precedes the oxidation ditch. The primary settling prior to an oxidation ditch is sometimes practiced but is not typical in the design process. The oxidation ditches have been reported to achieve a BOD, suspended solids, and ammonia nitrogen removal of greater than 90%. The typical oxygen requirement ranges from 1.1 to 1.5 kg of oxygen per kg of BOD removed and 4.57 kg of oxygen per kg of TKN oxidized, total kegidal nitrogen, that is TKN, total kegidal nitrogen. The sludge production for the oxidation ditch process ranges from zero point 0.2 to 0.85 kilogram TSS, total suspended solids, per kg of BOD applied. The typical sludge production is 0.65 kg TSS per kg of BOD. This is less than the conventional activated sludge facilities because of long sludge retention time. And the oxidation ditches are also applicable for treatment of wastewater that require nitrification, because the basin can be sized using an appropriate sludge retention time to achieve nitrification at the mixed liquor minimum temperature. This is the plan of an oxidation ditch. Here you can see the rotors are placed along with the flow of this wastewater. The influent coming from one side, and the shape of the oxidation ditch is oval. And throughout the length of this process, the whole wastewater is mixed with the air, and also mixed thorough mixing is happening. And during the resting period, that is 2 hours resting period is given to this wastewater flow. Then all the sediments will be, all the suspended solids will be settled at the bottom of the this oxidation ditch, and this can be collected through the sludge hopper. And the clear supernatant, that is effluent, can be collected at this stage. Then oxidation ditches designed with a multi-channel configuration with a ring, oval, or horseshoe shaped basin are called uh, racetrack type reactors. And these ditches have been found to treat quietly efficiently waste having BOD as high as 8,000 milligram per liter. These are the design criteria, that is cross section of the ditch channel, side water depth, the length of ditch, top width of the ditch channel, flow through velocity, volume of the tank, hydraulic detention time, solid retention time SRT, organic loading rates for warm temperatures, for temperature and normal temperature conditions, and volumetric loading rate. Then food to F by M ratio, that is food to microorganism ratio, is also given. Aeration capacity is also given. Then MLSS in the tank, mixed liquor suspended solid, is given. And the ratio of MLVSS to MLSS, that is mixed liquor volatile suspended solid to mixed liquor suspended solid ratio in the tank is given. Then suspended solids in effluent, then recirculation ratio for return sludge, oxygen required for BOD5 to be removed, then total kegidal nitrogen oxidized oxygen requirement, and air requirement is also given, then sludge production is also given. Then the advantages of oxidation ditches: it can be easily maintained. It is hard to be affected by load fluctuations and forms only little sludge. Oxidation ditches can be easily controlled by changing the rotation of the rotor and dipping the depth. It can perform nitrification and denitrification easily. This method is preferably used for treating wastewater from industries like pharmaceuticals, dairy, etc., located in densely populated areas. The system does not require primary clarifier and has less expensive sludge handling cost. Then oxidation ditches, the disadvantages: as the tank is large and the depth is small, it requires a large area for construction purpose. It can be said that the method is particularly suitable for small scale water treatment system used where sufficient funds and trained personnel are available and requires high power requirement. I hope you understood the oxidation ditches. Thank you for listening. See you in the next class.